In 1983, over 700,000 video game cartridges, mostly notably E.T. the Extra-Terrestrial, were buried in Alamogordo's landfill in New Mexico by Atari Inc., an American video game developer and home computer company founded in 1972. On December 30, 2001, the same city made international news when Christ Community Church held a public book burning of books in the Harry Potter series and several other series. Some years earlier, in the Jornada Del Muerto desert, not so far from Alamogordo, the first nuclear bomb test took place. This is a fact known to few people, but I'm sure things will change soon, because the new Christopher Nolan film, Oppenheimer, has finally landed, and I can't wait to experience it in the best possible way. Are you planning to do that as well? Let us know in the comments below. Initial impressions of the movie have been overwhelmingly positive. But wait, brace yourselves for a spoiler alert. Some have voiced concerns about a controversial sex scene between Cillian Murphy and Florence Pugh, claiming that it verges on offensiveness and racism. However, if you're a science enthusiast willing to set aside these issues, here's a little something that may enhance your movie-going experience. A glimpse into the fascinating science of Oppenheimer. First of all, for those of you that don't know about it, Oppenheimer tells the story of the scientist who created the first atomic bomb. He was amazingly intelligent as a kid already. When he was only 12, he was using the family typewriter to correspond with a number of well-known geologists about the rock formations he had studied in Central Park. Not aware of his youth, one of these correspondents nominated Robert for membership in the New York Mineralogical Club. And soon thereafter, a letter arrived inviting him to deliver a lecture before the club. Oppenheimer gave the speech and got a round of applause for his efforts, though he needed to stand on a box in order to see over the podium. You could really tell this kid would have gone far. Coming from a German Jewish family, Oppenheimer was also a really kind and generous person. In 1937, he used his own money to sponsor his aunt and part of her family when they fled their home to come stateside after Hitler rose to power. He was a great scientist, and he was one of the first ones to be interested in cosmic rays, a relatively new phenomenon for their times that had only been discovered in 1912. In 1931, he and a student named Frank Carlson co-wrote the first of many scientific papers about the physics of these rays of particles coming from God knows where in the universe. Nowadays, we know these are electrically charged subatomic particles that crash into our atmosphere, where they are broken up and fall to Earth in even smaller fragments, and we know a lot of them come from supernovae. Not only was he an incredible man of science, he was also deeply fond of poetry. He was actually a poet himself. One of his poems was even published in an issue of the Harvard literary magazine, Hound and Horn. He really enjoyed reading, and you can find Baudelaire, Shakespeare, Dante Alighieri, and Plato among the writers that shaped his vocational attitude and philosophy on life. Our 3 times Nobel Prize nominated guy never had the chance to actually win one, but he did get to take home the Enrico Fermi Award in recognition of his especially meritorious contribution to the development, use, or control of atomic energy. Oppenheimer was known for his chain-smoking habit, a habit that would eventually lead to his downfall. In 1965, Oppenheimer received the devastating news that he had throat cancer. Doctors attempted surgery, but it proved inconclusive, leaving Oppenheimer with a grim prognosis. He decided to try radiation treatment and chemotherapy, but these efforts would ultimately prove unsuccessful. As his health deteriorated, Oppenheimer slipped into a coma on February 15, 1967. Just 3 days later, on February 18th, he passed away at his home in Princeton, New Jersey. He was only 62 years old. A week after his death, a memorial service was held in his honor at Princeton University. The gathering was attended by 600 of Oppenheimer's closest scientific, political, and military colleagues. Among them were notable figures such as Hans Bethe, Leslie Groves, George Kennan, and Eugene Wigner. After the service, Oppenheimer's body was cremated and his ashes were placed in an urn. His wife Kitty took the urn to St. John and released it into the sea as a final farewell to the man she loved. In the years following his death, Oppenheimer's legacy continued to be recognized and honored. In 1970, a lunar crater was named after him, and on January 4, 2000, an asteroid was also named in his honor. As you can see, the story of Oppenheimer is not just the story of the creation of the first atomic bomb. It is the story of a human, with his flaws and qualities, with his passions and problems. Can't wait to see how the movie will unveil the life of one of the greatest physicists of all time. The science behind the nuclear bomb. Atoms. To better understand the movie, you have to know how an atomic bomb works, which in turn requires us to go back to the infinitesimally small atoms. At the heart of an atom lies its nucleus, where protons and neutrons huddle together. Protons are positively charged, neutrons have no charge, and electrons carry a negative charge. With equal numbers of protons and electrons, an atom remains neutral. But here's the twist. Changing the number of protons or neutrons can drastically alter an atom's behavior. Adding or subtracting protons creates a completely different element, while adjusting the number of neutrons results in isotopes. Let's take carbon for example. It has 3 isotopes. 1. Carbon-12. It boasts 6 protons and 6 neutrons, making it a stable and commonly found form of carbon. 2. Carbon-13. With 6 protons and 7 neutrons, it remains stable yet rare. 3. Carbon-14. This isotope has 6 protons and 8 neutrons, making it both rare and unstable or radioactive. While most atomic nuclei are stable, a few are just a bit more rebellious. These unstable nuclei spontaneously release particles, which we call radiation. When a nucleus emits radiation, it becomes radioactive, and this process is known as radioactive decay. There are 3 types of radioactive decay to consider. 1. Alpha decay. The nucleus kicks out an alpha particle consisting of 2 protons and 2 neutrons tightly bound together. 2. Beta decay. In this case, a neutron transforms into a proton, an electron, and an antineutrino. The emitted electron is what we call a beta particle. 3. Spontaneous fission. As the name suggests, the nucleus splits into 2 pieces, neutrons and gamma rays. A burst of electromagnetic energy may also be released. Pay close attention to spontaneous fission, as it will play a significant role when we explore nuclear bombs. So when we say an atomic nucleus is stable, it means its content doesn't feel the need to change. But when it's unstable, it seeks excitement and emits radiation. This radiation can come in the form of particles or energy bursts, and it's what makes radioactive decay happen. The science behind the nuclear bomb. Nuclear fission. Nuclear bombs are all about the forces that hold atoms together, especially the ones with unstable nuclei. There are 2 ways the nuclear energy can be unleashed from an atom. The first way is called nuclear fission. It's like splitting an atom right down the middle using a neutron. When this happens, the atom breaks into 2 smaller parts. This splitting process releases a lot of heat, energy, and radiation. The second way is called nuclear fusion. It's like bringing 2 smaller atoms closer together until they join and form a larger atom. This process also releases a lot of heat energy and radiation. Nuclear fission was discovered by the Italian scientist Enrico Fermi. In the 1930s, he showed that if you shoot neutrons at certain elements, they can transform into completely different elements. It was like a magical transformation. After Fermi's discovery, other scientists named Otto Hahn and Fritz Strassmann tried shooting neutrons at uranium. Guess what happened? Uranium split into smaller pieces and released a radioactive substance called barium. This finding made them realize that low-speed neutrons can cause the nucleus of uranium to break apart. But here's the exciting part. When uranium splits, it releases even more neutrons. This got scientists thinking. Could these free neutrons start a chain reaction that releases a massive amount of energy? If so, they could create a super powerful weapon. And that's how the discovery of nuclear fission by Enrico Fermi led to the creation of the first atomic bomb. By splitting atoms and causing a chain reaction, scientists were able to release an enormous amount of energy and create a weapon like no other. Where was Robert Oppenheimer when all this was happening? He was busy studying quantum phenomena such as quantum tunneling and energy levels of the multi-electron atoms. He was also involved in radioactivity research, and in 1930 he even predicted the existence of a new particle, the positron. Then in 1942, our buddy was recruited to work on the Manhattan Project, and in 1943 was appointed director of the project's Los Alamos laboratory in New Mexico, tasked with developing the first nuclear weapons, 4 years after the start of the German nuclear weapons program. His leadership and scientific expertise were instrumental in the project's success. On July 16, 1945, he was present at the first test of the atomic bomb, Trinity. In August 1945, the weapons were used against Japan in the bombings of Hiroshima and Nagasaki, which remained the only use of nuclear weapons in an armed conflict. Vocabulary: Calutron. In the next few minutes, I'll take you on an adventure to explore some key concepts that will unlock the mysteries behind the movie. Buckle up and prepare to be amazed. Our first stop on the scientific roller coaster is the intriguing realm of the calutron. Now you may be wondering, what on earth is a calutron? Well, my friends, it's a genius device that played a pivotal role in the creation of nuclear bombs. Yep, we're diving deep into the atomic world. Let's start with atoms, those tiny particles that make up everything around us. Take uranium, for example. It's an element with multiple isotopes, the most common being uranium-238. But here's the kicker. To make nuclear bombs, we need a specific isotope known as uranium-235. Now, separating uranium-235 from uranium-238 is like searching for a needle in a haystack. These isotopes have almost identical properties, making them devilishly hard to distinguish. That's where the calutron swoops in. Picture this. You have a box full of marbles, mostly red, uranium-238, and a few blue, uranium-235. Your mission: retrieve only the blue ones. The calutron acts as your trusty sorting machine, armed with magical powers to detect the tiniest of differences. Here's how it works. First, uranium is transformed into a gas. Then, this gas is pumped into the calutron, where it encounters electric and magnetic fields. These fields manipulate the paths of the uranium atoms based on their mass. Think of it as a magnetic force gently nudging marbles of different weights in various directions. The lighter blue marbles, uranium-235, are bent more than the heavier red ones, uranium-238. Voila! The isotopes are separated, and the concentrated uranium-235 is now ready for its explosive destiny. During World War II, calutrons were unsung heroes, tirelessly enriching uranium for the first atomic bombs. Without them, the bomb's power would have been insufficient for the devastating impact we witnessed. They paved the way for nuclear technology, revealing the incredible power and weighty responsibility that comes with unraveling the energy trapped within atoms. After the war, other methods of enrichment became more common, but calutrons were a crucial first step. They paved the way for nuclear technology and showed us both the incredible power and immense responsibility that comes with harnessing the energy inside atoms. Vocabulary: bosons and fermions. There are only two types of fundamental particles known in the entire universe: fermions and bosons. Every particle, in addition to the normal properties you know like mass and electric charge, has an intrinsic amount of angular momentum to it, colloquially known as spin. Particles with spins that come in half-integer multiples are known as fermions. Particles with spins in integer multiples are bosons. There are no other types of particles, fundamental or composite, in the entire known universe. The dramatic difference in behavior between bosons and fermions has led to a sociology of fundamental particles. It has been established that bosons are social and gregarious, while fermions are antisocial and aloof. Vocabulary: new physics. Perhaps you'll hear the word new physics while watching the movie, and you'll wonder what exactly that means. Don't worry, I'm here to make your life easier. New physics is just a term used in the mid to late 20th century to describe the rapid evolution of discoveries in the field of physics. In particular, this movement included the development of quantum mechanics, a field that proved essential to Oppenheimer's pursuit because it enabled researchers to create tools like the calutron, as well as understand the mechanics of fission and fusion. Vocabulary: mass, energy, equivalence. Mass energy is the energy associated with a body of a specific mass. Indeed, physics tells us that these two quantities, mass and energy, are equivalent, and they are indissolubly related by the famous equation E equals mc squared discovered by Einstein. The value of the speed of light is 186,000 miles per second, and it is therefore a huge number. This means that a small amount of matter can be equated to a very large amount of energy and vice versa. However, the possibility to transform mass into energy only occurs in some special cases. One of these is nuclear fission. Vocabulary: nuclear fallout. When a nuclear bomb goes off, or there's a nuclear accident, it releases a ton of crazy energy and sends radioactive particles flying into the sky. These tiny radioactive particles are like the sneaky hitchhikers of the nuclear world. They ride like the wind currents and settle back down to Earth, sometimes far away from where the bomb or accident happened. That's the fallout part. And here's the bummer. These radioactive particles can be dangerous to living things because they emit harmful radiation. They can mess with our cells and cause all sorts of health issues, so definitely not a chill scene. But the good news is scientists and governments are totally on top of this. They study fallout patterns, predict where it might go, and take precautions to keep people safe. So while nuclear fallout isn't a rad thing, we're doing our best to handle it responsibly and protect everyone from its not-so-cool effects. The life of Robert Oppenheimer was truly remarkable. Not only was he a brilliant physicist who played a crucial role in the development of the atomic bomb, but he was also a multifaceted individual with a deep appreciation for literature and poetry. His contributions to the field of science, from his early work on cosmic rays to his leadership in the Manhattan Project, were nothing short of extraordinary. However, Oppenheimer's story is not without its tragic elements. His chain-smoking habit led to his untimely death from throat cancer at the age of 62. It is a reminder that even the brightest minds are not immune to the consequences of their actions. Despite the controversy surrounding his involvement in the creation of the atomic bomb, Oppenheimer's legacy continues to be honored. From lunar craters to asteroids named after him, his name lives on in the annals of scientific history. As we wait to experience the movie about his life, it is clear that he was not just a scientist, but a complex human being with flaws and virtues alike. His story serves us as a reminder that even the most brilliant minds are not devoid of humanity. The good, the bad, and the definitely interesting. Today, let's take a deep look into one of the most popular sci-fi movies of the decade, Interstellar. In case you forgot how the movie went, here's a really brief recall. The movie was set in a dystopian Earth, where there is a massive blight slowly causing a lot of crops to become extinct. Now obviously it is easy to see how this would be a problem, right? So NASA, which is a now secret government project, spends all their time and energy in finding our next home. A pilot stumbles upon the coordinates of this secret agency, travels to this place, and gets recruited to be the designated driver for mankind's search for its next home. That's basically the plot of it. Scientists looking for a way to salvage the rest of us by looking for Earth number 2, with a lot of extra elements to it, of course. It's a sci-fi movie after all. If you're a fan of science, surely the movie must have been an absolute delight due to the buffet of information to ponder upon. What caused the blight in the first place? Can there possibly be wormholes out there? Does gravitational lensing really work as depicted around the black hole? Does time really go faster around a more massive object? The manipulation of gravity. I could go on, but for the sake of the video, let's pick a few of these and describe the science behind the events. Before I go on ahead explaining, I think it's appropriate to place a spoiler alert here. I know, the movie is almost 6 years old, and to be honest, I would be very surprised if you hadn't seen it yet, but hey, It wouldn't hurt to have a bit of courtesy, right? First, let's talk about the highway that the Endurance went through to get to the other side of the universe: wormholes. In the movie, one challenge that NASA faced was bringing a spacecraft to a galaxy where there is an abundance of viable planets, as if God himself watched over this mission. A wormhole opened near Saturn and instantly connected the crew into the other galaxy, where 3 possible new Earths are within reach. Romilly explained wormholes to Cooper this way. Well, okay, I wouldn't credit Rom for this, since it's how wormholes are generally explained to folks who are not that strongly science inclined. Drawing on a piece of paper, Romilly drew 2 X's at the top and the bottom. The closest point between these 2 points is a straight line, but if you can fold the paper in such a way that the 2 points instantly touch, then you practically save time. Now on paper, that doesn't sound like a lot of savings, but if it were in space, in the vast outer space, imagine years of travel that can be compressed into just months or even hours. If you don't yet get the gravity of how fast that travel can be, it's basically faster than the universe's speed limit, the speed of light, even though you can say that it's some kind of cheating in a way. Unfortunately, the concept of wormholes are nothing but theory, as this is what general relativity suggests due to the distortion of space-time due to gravity. However, the movie did great justice in presenting how this expressway might look in case we actually ever find one: a sphere suspended in space that seems to be a blurry mirror. And of course, if we ever get to finding one in the future, you'll be sure that we will feature this here on this channel. So next, the Endurance spacecraft travels through this wormhole and arrives at a new stellar system. And it's not just any ordinary system, it's one that is awfully close to a black hole, to which 2 planets are orbiting around. The first planet that the crew decided to land on, Miller's planet, has a lot of shallow waters. At this point, there are 2 very important and interesting events that are going on. Let's talk about the first one. As the movie progressed, the crew on the surface saw something which they thought were mountains. Later on, this was revealed to be actually a gigantic tidal wave. Take note of the word usage here. It's not a tsunami, but a tidal wave. Why is that? Well, try to recall how tsunamis are generated. Remember, they are a consequence of some kind of geological activity in the ocean, right? Either an earthquake or a volcanic eruption, or some kind of underwater explosion. And since none of these were shown in the movie, we couldn't really call it a tsunami, right? Okay, now let's discuss how waves are formed. They are a product of the moon's tugging of the water from Earth due to the gravity, right? Remember, what's exactly close to this planet in the movie? A massive black hole. And what do black holes have plenty of? Gravity, of course. Now, with that extremely strong pull of gravity, most of the water in the planet is pulled to a height to form a gigantic tidal wave. Of course, in reality, the wave should just be a blob, but hey, we need to give the creatives some room to create drama, right? If there was a boring blob instead of a tidal wave, then our lead characters wouldn't have that much consequence to their actions, wouldn't they? Moving forward, let's talk about the second important point about Miller's planet: time dilation. If you can remember the movie, the Endurance crew carefully deliberated before landing on the planet due to one unexpected resource depletion. They're gonna lose a lot of time. Moreover, this point is highlighted when they realize that Miller hasn't been actually transmitting data for several years. It's actually a lag in the transmission due to the time difference. After the events on the planet and returning to Endurance, the protagonist came to a realization that more than 23 years had actually passed despite having seemed to have only spent a few hours on the planet. Now, you may think this is a crazy concept, but Einstein's theory of relativity would disagree with you. In general relativity, it was explained that objects with huge mass messes up a lot with the fabric of space-time. Specifically, the closer you are to an abnormally massive object, space-time stretches more. Think of having a stretchy kind of ruler. At normal conditions, a centimeter to that unstretched ruler is still a centimeter, right? But if you put a heavy object at the end of that ruler, obviously the units of measurement stretches, and a centimeter in the ruler isn't the same anymore. The same thing happened to our protagonists on Miller's planet. Due to the presence of a black hole, space-time is stretched a lot, so much that time passes slower there. If you're hoping to be immortal, at least to Earth standards, this is one cheat you can use, assuming you can find some place similar to Miller's planet, of course. Now, I know you're thinking whether this is purely theory or can we actually observe it in our daily lives? Well, the answer is not that far away, my friend. GPS satellites experience a faster time since they are farther away from the center of Earth's gravity. Scientists knew this long before, so they took this to account and set up compensation measures to guarantee accurate transmission of data. If you've made it this far into the video, I know you've been waiting for me to talk about the most interesting and definitely most talked about part of Interstellar, the black hole. The fastest thing anybody would notice with Gargantuan was that the disk at the other side seems to appear on top and at the bottom of the black hole. This is due to an effect which, again, Einstein predicted, called gravitational lensing. To understand this better, let's recall how lenses work. In its most basic function, lenses practically refract light so that its focus changes, right? It changes the direction of the light that's coming through our eyes so that we could focus on it better. Now, if you recall, general relativity predicts that massive objects curve space-time. If that's true, since light travels through space, it will have no choice but to similarly bend in the presence of a really strong gravity. This is what we call gravitational lensing. This phenomenon results in the beautiful horizontal and vertical rings we saw in the movie, the vertical one being the result of extreme lensing due to the mass of the black hole, and the horizontal one as the black hole's accretion disk, teeming with energy. And again, this is not purely theoretical, as this has been observed several times already ever since Einstein's publication of general relativity. And have I mentioned he already hypothesized this phenomenon to be possible long before he published his paper? Talk about an absolute genius. Another thing that's been highlighted about black holes in the movie was the protagonist, Cooper's brave sacrifice to get sucked into Gargantua in order to propel his colleague into the final planet that might just be the next Earth that they are looking for, Edmund's planet. Now, if you're a fan of astrophysics, I'm guessing you went mad when Cooper went in, traveled straight into the event horizon, and got into another place in one piece. Well, my dear friend, I want you to calm down a bit so I can offer you a few explanations to that. As explained in the movie, Gargantua is what is considered a gentle singularity. For the purposes of the film, what that actually means is that there's a chance you might survive the event horizon once you attempt to travel into it. Now, what happens when you get across, that's what's going to be the surprise inside the box. A new universe? The same wormhole they traveled in? No way of knowing at that point. Although that is not to say that you wouldn't meet your demise. As soon as you jump into the event horizon, there's no way but to go deeper. It's just that in the movie there was an artificial placement of what they called a tesseract by some bulk beings. More on this later. Neil deGrasse Tyson took a stab on the possibility of survival when falling into a black hole. According to an interview he did in 2014, he explained that if you are going to beeline straight into the event horizon, your destiny is inevitable. You'll be spaghettified faster than you can say pasta. However, if you followed a certain trajectory curve balling your way in, then you just might survive. Take note of the just might there. As you know, all of these are purely theoretical, of course, and physicists are trying to narrow down the specifics of that. And the buffet of cosmological knowledge doesn't end there. Upon jumping into the black hole, Cooper and the AI TARS ended up in a place which they called the Tesseract, a crazy, out-of-this-world place where Cooper could see his past selves as if they were books on a bookshelf, free to access the events of his life before leaving for the mission. What they realized here is that they are in a place where time is a physical object they can have access to any time. In our universe, we perceive things to have 3 dimensions, some height, width, and then length. However, in the Tesseract, being a 4-dimensional space, they are free to influence the 4th dimension, time. Let's make a parallel analogy to understand this better. Say, for example, you are a 2D person. All you have is length and height, and you live in a piece of paper. Say I, a 3D being, place a mug on that paper. In your world, you would perceive this to be nothing but a line, but to me, it's a mug. And when I change the position of that mug, you'd be amazed by how that line suddenly disappears and reappears in your space as if it's magic. Credits to Edwin Abbott, who wrote Flatlands for this analogy, by the way. Now, this is what was portrayed as bulk beings in the movie. From their perspective, time is the mug that they can freely move about anywhere they like. But to us, it's a magical thing that's beyond our understanding and control. This is what Cooper and TARS experienced in the last few moments of the movie. They finally found out the secret to manipulating space-time. and relate it to a time in the past using a watch that he gave to his daughter, Murph, which of course led to the salvation of mankind and a loopy space station near Saturn. If you would get marooned on a desert island, how confident are you that you would survive? How about if the desert island is Mars? Let's talk more about this on today's episode. What's the worst you've ever been stranded on? Have you ever been lost in a place you're extremely unfamiliar with? Or some rural area where there isn't any internet or even electricity? Or maybe you've gone somewhere extreme. Have you ever been lost on an island due to some circumstances beyond your control? Well, if you're the last one, I have nothing but mad respect for you, sir or ma'am. If you're watching this, it's most probably that you survived that ordeal, and that's awesome. I'm not saying any struggle is comparable against one another, but I think Ridley Scott's The Martian will definitely show you the worst possible level of being stranded you can ever get. I personally prefer this one, as this is one of the best works of sci-fi that didn't settle down for complete fantasy over facts. In fact, one of the screenwriters, Drew Goddard, specifically mentioned that they weren't going to dumb the movie down, since they know they will have a smart audience, and boy did they deliver. The movie describes the experience of astronaut Mark Watney as he was left for dead on Mars. Before you get mad at his mission crew, it's important to note that it's not their fault entirely. I mean, Mark was basically hammered away by some debris as there was a gigantic storm ongoing. Their commander had to make a tough decision on the spot, and that's not always a happy one. But enough about that. Today let's learn about Matt Damon's solitary experience on Mars. Today let's list down tips that will serve as a guide on how to survive if ever you get stranded on the Red Planet. Of course, while exploring the science behind each item as we go through them. Who knows, maybe the first person who will actually be stranded on Mars is one of the viewers of this show. At least, whoever that is will have a hint of what to do. Tip number 1. When there's a storm, always wait it out. The Martian wasted no time and kicked off the movie with a gigantic storm that resulted in the main conflict of the film, Watney being separated from his crew. But it's not like they didn't know this was coming. They detected this on a forecast and deliberated whether they will stay or will go. And if you have seen the movie, I think you already know how that discussion went. I think it wouldn't take a genius to know that you shouldn't get out when there's a storm forecasted to strike you down 8,600 newtons of force, making this our tip number 1. However, do storms like the one in the movie really happen on Mars? According to studies, despite having only 1% of our own atmosphere, which means they have a really small amount of gas, it is possible to have dust storms on Mars. It was even said that these storms could get so wild that they cover the entire planet. But these winds are not that strong. They can only go between 15 to 30 meters per second. This speed can carry small particles like dust, but is highly unlikely to cause a storm that can topple down a towering spacecraft. The science isn't looking good so far, but come on, you gotta give the creatives a lot of room to move the story, right? Tip number 2. Keep calm and do the science. It wouldn't take a genius to realize that the best part of the film is how composed and collected Mark Watney was, despite facing the largest predicament of his life. As he beautifully stated in the film, he had to science the cheese out of it. Of course, he didn't say cheese. We had to change that for obvious reasons. He knew that he was going to be waiting for the next manned mission for an absolutely long time. So what steps did he make? He sat down and did an inventory of his supply. He found a way to stretch whatever limited resource he had, and he devised a way to communicate with Earth and tell everyone, "Hey, I'm alive." This is a very refreshing take for scientists, right? In movies, they are almost every time depicted as weirdos that are sometimes disabled by their own human nature. Sometimes they can get too evil, too greedy, or too nihilistic, but the movie didn't show folks that way. It is important to note that it's not just the lead character that has this attitude, but also the rest of the Ares crew aboard Hermes and the ground crew. A problem is a front, and instead of scrambling, they gather themselves and work towards a solution. And if you ask the scientist in JPL, they will tell you how happy they are that the astronauts are depicted with this level of care and accuracy in the movie. Truth is, when you're in space, there isn't going to be much room to be a burden and compromise everybody because of your emotions. It's going to be as harsh and unforgiving, so you better bring your A game. Tip number 3. Stretch your resources. As soon as our protagonist realized that he's going to be on Mars for a long time, he immediately counted his rations and forecasted how long it can sustain him before the next mission arrives on the planet. And the result? He didn't like what he found out. His supply will run out long before Ares 4 arrives. Luckily, he found potatoes that his crew had been saving for Thanksgiving. And did he turn it into fries immediately? Not by a long shot. Being the mission's resident botanist, he knew he had to turn these to crops using Martian soil and his own excrement. A real stinking experience if you asked me. And growing crops doesn't end with just cultivating the crops and laying down your plant. You will need water in order for this to work, and that resource is limited too. So how does our hero tackle this problem? Did he look for a well, or maybe did he find a lake where he can carry a pail and fetch some water to bring to his hab? Did it rain on Mars sometime? Okay, so where did Watney get his water? If you're constantly getting your updates about Mars, then you will know that there isn't any available natural source of water on the red planet yet. However, our main guy solved this problem by taking some excess hydrazine from their ship, and with a little help of some chemistry knowledge and a few explosions, he managed to create a room with the necessary amount of water vapor. Now it's time to tackle the science presented. First, is it really possible to grow potatoes on Mars? And admit it, if you've seen The Martian, this is definitely the prime thing that you're desiring to get verified. The closest answer we got is from a collaborative study by NASA and the International Potato Center. In this experiment, they attempted to grow potatoes on an emulated Mars-like environment. The temperature, the day-night cycles, gases, air pressure, and the sand were all supposedly as close as the actual thing on the red planet. The results they got? They managed to grow a sprout. However, this doesn't validate the possibility. Keep in mind that this is emulated. All the experiment says is that it's definitely highly likely, but until we're there, there's no way of telling for sure. Okay, so how about the water? Well, yes and no. Yes, technically you can create water through hydrazine. You heat it up to 1073.15 Kelvin. Yes, I used Kelvin because that's how we should discuss temperature, while in contact with either platinum or iridium. This gives you nitrogen and hydrogen, which you collect in droplets. Let that combust with oxygen and boom, you have water. Then there's the no. Actual science suggests that the amount of heat needed to generate that amount of water would have burned down the hab. There's this suggestion that he could have just extracted the water from the soil, but that's another story. So much for being a botanist, huh? But the effort dedicated for both these scenes checking out is definitely outstanding. And hey, if you want to see how that water extraction is possible, why don't you leave a message in the comment section down below? Who knows, we might just cover that. Tip number 4, find a way to communicate. So one of the next steps that Watney performed after he established sustenance is finding a way to connect with home base. He realized he could salvage Pathfinder, an old retired probe from an older mission. Now, you may not have heard about this little guy, but this is one of the most memorable missions of NASA's JPL, since this is the first time they have to utilize a new, more cost-efficient way to land on Mars, precisely without using so much rocket propulsion. Why did they have to do that? Well, there was the issue about budget, but let's not go into that tangent. So what JPL did instead is that they just covered Pathfinder with balloons and just practically dropped it into Mars. I swear that happened, look it up on YouTube. Okay, let's go back to The Martian. Watney's recovery of this probe was a challenge. First, the rover that he has only has a battery life good for about a few kilometers, so he had to scavenge and engineer a power system using a battery from another rover. Then, driving there, he had to deal with the problem of the night drives being extremely cold. How did he deal with the second one? Well, space missions come with a radioisotope thermal generator, or an RTG for short. Basically, a naturally decaying plutonium-238. No controls needed. It's just a nuclear reactor that's been converted as a heater. Now, it wouldn't take a genius to wonder if this is even safe to do, right? I mean, we're all aware what happens when a place is exposed to a nuclear breakdown. Well, Watney wouldn't be a survivor if he hadn't thought about that. Theoretically speaking, as long as the protective graphite sheet covering the plutonium remains intact, he'll be safe. Okay, so he recovers Pathfinder, sets it up, and voila! He has a way of communicating to Earth with the limited technology that he has. I hope you're taking notes so far, because now we're going to the last item. Tip number 5. Patiently wait for help to arrive. So you've got your supplies set, you've got your message for help. I think there is nothing else to do but wait for rescue to arrive, right? The movie didn't make it that easy. Supposedly, JPL was going to send some supplies to Mars to help Watney survive until the next manned mission arrives. However, it wouldn't make a great movie if they didn't add more drama to it, right? Watney accidentally blew up the hab, which destroyed his beloved potato crops, which means that the crew here on Earth had to double the speed of producing the supply payload and launching it into space, and that speeding up had consequences. The Iris rocket blew up just before it exited the atmosphere. Now, we have a lot of tension. Watney came to terms that he is going to die soon. However, there is still one gambit up NASA's sleeve. Hermes can still pick up the payload in exchange for more time in space. This is where it gets interesting. There isn't really anything special on the way that Hermes picked up the supplies for Mars. It's just beautiful astrodynamics executed. In the movie, the crew pulled off a move called the Rich Purnell Maneuver. What they basically did is, instead of slowing down as they enter the Earth's gravitational field, they accelerate so that they can get captured with just the right amount of grip to effectively spin them around and then slingshot them towards Mars. Sounds pretty easy, right? I know a lot of you highbrow science fans will say they just added it there to make the film more interesting. I doubt that it's even accurate. Well, boy, do I have a surprise for you. In 2015, Laura Berg's study confirmed that this move in The Martian is definitely accurate and wouldn't be beyond the laws of physics. However, and if you're a real fan of science, you know that there's always a however. It won't be economically efficient. There's this chance of the Hermes getting a bit of influence from Venus's orbit and messing everything up for the crew. But still, you have to give it to Andy Weir for sitting down and doing the math and making sure the science is right. With all these tips that we gave in today's show, I hope if ever you're the one that gets to be the real Mark Watney in the future, you have a little idea of how to handle yourself and pushing yourself to survive in one of the harshest locations you can ever be left behind. Today we will discuss one such fascinating movie, Ad Astra. We have seen movies about the existence of aliens, our contact with them, but not about the opposite. What if we are alone in the universe? Ad Astra, to an extent, addresses this question, and with a unique approach. As said by C. Clarke, there are two possibilities. Either we are alone in the universe, or we are not. Both of these ideas are equally terrifying. What if we are alone in this vast universe? What if we are all that matters? If that's the case, why is it? Until now, we don't have any perfect plan to live and sustain in outer space. We read and hear speculations of life on different exoplanets that exhibit Earth-like features and believed to be habitable, and still, we have found nothing. It's a very intriguing question that has not only baffled me, but many scientists around the world. Ad Astra depicts the endless human pursuit to find life in space. If you've watched the movie, let's briefly discuss what happens in it. But before that, let us give you a spoiler alert. And all those who haven't watched this movie, go watch it, guys. Ad Astra revolves mainly around the protagonist, Roy McBride, who is a fearless, lonesome astronaut who is one of the best in his company. He inherited his father's passion and reputation, who was also a very famous astronomer. They observed a sudden power surge of gamma ray bursts on the Earth, causing deaths of over 40,000 people around the world. When the scientists at the Spacecom, a NASA-like government organization in the movie, observed this surge, they discovered that this gamma ray burst came from Neptune. Roy's father, Clifford McBride, was a legend. He was the first man to go to Jupiter, Saturn, and Neptune in what they called the Lima Project, but scientists later lost communications with him. Roy is then informed that his father might be alive, and the cause of this gamma-ray bursts was the Lima project. Roy is then asked to go to Mars and contact his father. Later, he comes to know that his father might be the cause of the surge. His father was the captain of the Lima project and was very determined to find life in outer space. But the loneliness and being far from home affected his fellow crew members. They wanted to go back, but Clifford was so determined to find life that he killed all those who mutinied against him and cut off all the communications with Spacecom. Eventually, he killed the last of the surviving ones too, and during the fight they caused a power surge near Neptune. Ad Astra deals with a very different and uncommon idea of extraterrestrial life. The movie not only elegantly describes human exploration to space, but also a vivid description of what it is like being in space. What if we are really alone in the universe? Or maybe we are not intelligent enough to communicate with them. It could be because they are more intelligent than us, or they might be single-celled organisms. If that's the case, what does it mean for us? The movie revolves around this central idea. The movie begins with a psychological evaluation of Roy, which tells us how important it is for astronomers to be in the peaceful state of mind. We see a giant tower also, which speaks about the high ambitions of humans to look out in space. In the coming years, space travel will be developed and easier. Through companies like SpaceX and Virgin Atlantic have laid out plans for space travel, but still there is a lot of work to do. The movie shows that commercial travel to space will be a very common thing, with humans going to the moon and space. Even though we will be very advanced and developed, our human consciousness and behavior will be the same, and this theme is very successfully presented in the film. We can see when Roy travels to the moon, he has to even pay for his pillow, and it's like the commercial planes of the current time. The movie draws a picture of how human exploration and colonialism would look like in the coming years. No matter how much advanced we become, humanity will always follow us. The movie tells us that few things will change. Companies and restaurants existed before and will exist today. Even on the moon, we see original companies that exist today and will probably exist soon. If we look 50 years back and think about what has changed, we observe that not much has changed for humans. Fast food restaurants like McDonald's and others existed way back, and they will exist too. What will the moon be like when the humans colonize it? Well, probably it will also be not much different. There will be disputed land and borders between countries. There will be controversies for natural resources, and countries will have secret treaties between them. There will be unexplored and no man's lands that will have thieves and pirates, much like the terrorist organizations today. Overall, the human nature will not change. We will always fight and deal amongst ourselves, whether on Earth or in outer space. Mars is depicted very finely in the movie. Mars has a network of underground tunnels or lakes, and Roy uses one to illegally go to the test site. Mars also has many lava tunnels, which are used for accommodations of humans in the movie. They are a very plausible way for accommodation of humans because they already exist. The movie also addresses a very subtle element. It's the human psychology. It addresses this point that how the psychology of astronauts are affected from traveling into space, how weary the journey is for them, and how it affects their mental condition. No matter how dedicated they are to their work and projects, only 200 miles above the Earth, when they see the Earth, they see home, and that vision, that view of the blue marble affects them. They are still grounded and rooted to who we are as a species. People that have been to the moon have seen the Earth as a celestial body in a sea of celestial bodies, and that triggers a very negative feeling. All the people that have been to the moon and look up and see the Earth, all of the psychological questions become quite different. Loneliness creeps in and it forces them for reassessment of what it means to be part of this human race. Of all the 12 Apollo astronauts that have been to the moon, most of them have been somehow affected by it. Neil Armstrong went to live on his farm in Ohio and they heard not much from him. Buzz Aldrin has been very open about his alcoholism and depression he faced after returning. Ed Edgar Mitchell started talking about aliens. There was a greater need for those men who saw the Earth in such a state and tried to attach themselves with some greater meaning. They had to undergo an existential crisis, and that is very clearly depicted in the movie. Imagine what it would be like in outer space, and going as far as places like Neptune and beyond. The darkness and the unending infinite space which makes us feel extremely small and would affect our psychological state. Roy McBride is depicted as a lonely astronaut without any family, in a way that he was a perfect astronaut to go on any missions. We can relate this with the choice of astronauts made even today. Organizations prefer people who love to be alone and not question their inner lives. A normal person will be affected beyond imagination from the dark, endless void of space. People are invited for conducting experiments where they are made to stay in close quarters for a long time. And for that, they need a very special kind of people, those who are loners. An excellent example will be Neil Armstrong. After coming back to Earth and addressing the media, we can see in his interview that he talks less about what it was like to remain in space, to see the first man to set foot on the moon. Rather, he talked about the engineering and physics behind it. He was the perfect person for them. So we can imagine how NASA and other organizations make their choice. The journey to Neptune was bizarre and erratic. The journey tells us what it means for the people of Earth to be in space. It deeply affects them. Their behavior changes, their ideas change. They face a crisis in their mind. Roy, though he was a loner in the long run, endless infinite space did a number on him. The darkness of space is cruel, which brought a surge of thoughts in his mind. Astronomers are deeply affected. They get flashbacks and monologue starts. Roy's father was so bent on finding life in space that he could not face the fact that we might be alone in this universe. He was so obsessed to find intelligent life and give meaning to his life. But he couldn't. In the end, he asked his son to let him go into space and succumb to his failure. The movie tells us we are very optimistic about finding life in space and naming habitable planets, but still, we have no success. We have never entertained the fact that what if we are alone in this infinite universe? And that's worrying and terrible. More terrible than the presence of intelligent life, because if that's the case, we have to rethink our approach. Why are we so special then? And what should we do then for the future? The universe appears to be dead and empty. No one's sending us messages and no one answering our calls. We might be completely alone, trapped in the universe. If we let life on this planet die, it can be that all the life in the universe would end. Does that scare you? If yes, then no problem. You are having the correct reaction. It's always good to be optimistic, but we should think about the possibilities. There are many science fiction movies that make you feel fascinated. One of those films is Gravity. Join me on this journey. Alfonso Cuarón's Gravity is one of the most beautiful, terrifying, moving, and promising films about human survival we've ever seen. That's one review that can describe the film Gravity. It is one of the most shocking cinematic experiences, and certainly one of the best films we have ever seen. Gravity, which opened the curtain of the 70th Venice Film Festival, left the audience speechless, and we are going to analyze the reasons why. So let's start. The film was released in cinemas on October 4th, 2013, and received very positive reviews, considering it was a space masterpiece, and became a huge success with total receipts reaching $716.3 million. Received 10 Oscar nominations, including for Best Film and First Female Role for Bullock's performance, winning the Academy Award for Director and 6 other statuettes in technical categories. He was also awarded the Golden Globe for directing from a total of 4 nominations and 6 BAFTA out of a total of 11 nominations. Director and co-writer Cuarón brilliantly manages to create both awe at his glorious space vistas and knuckle-gobbling tension at what's happening in the foreground. You could find yourself asthmatically gasping with rapture and excitement at the same time. In order to give this film life, he worked for almost 4 years, on how he would present this magnificent work. In a real and rare modern cinema delirium of visual perfection, choreographed action and great melodramatic intensity, Alfonso Cuarón, in the film he seems to have wanted to direct all his life, takes you into space from the first second of the opening, and he doesn't let you set foot on Earth until you have completed an existential thriller of an emotional roller coaster that annihilates with breakneck speed and constant turbulence all the distance that separates the awe of man's insignificance in the universe from terror in the face of absolute emptiness. Let's take a closer look at the film. Alfonso Cuarón's incredibly exciting, visually amazing film is about two astronauts floating in space. Sandra Bullock plays a scientific engineer, a scientist of genetics. Dr. Ryan Stone, who after 6 months of training, she travels for the first time in space to attach a high-tech new scanning device to the Hubble telescope. She is under the watchful supervision of Matt Kowalski, a genial and grizzled space veteran played by George Clooney. She is accompanied by Matt Kowalski, who is on his last flight before retiring. The voice of Houston Mission Control is played by Ed Harris, in playful homage to Ron Howard's 1995 space disaster classic Apollo 13. Only this time it is him telling them about the problem. Soon a terrifying situation unfolds. The ship disintegrates and Stone and Kowalski are left alone in space, hooked only to each other in an endless descent into darkness. Their deafening silence confirms that they have lost all contact with Earth and all hope of salvation. As fear turns into panic, every breath reduces the oxygen they have left. But the only way to return may require them to sink even further into the terrifying vastness of space as they try to survive. The expert astronaut's instructions will keep her alive until there's no other option. A return to base is a solution. The rope will be cut and Kowalski will leave her alone in space. And from this point on, the thriller will take a grotesque turn when Ryan is constantly confronted with death, but she keeps getting away with it. This happens either by finding accidental a fire extinguisher and extinguishing the fire from mechanical failure, or at a difficult time, Kowalski will appear and making the space-Earth route will keep it in rather than an upright on the T with death. There is three-dimensional realism that leaves you speechless, a survival thriller that flirts with existential drama, and an adult sci-fi adventure that delivers as little Hollywood convenience as possible. It's obvious to think, even before you see Gravity, that a story with only two heroes lost in space brings with it an intense symbolism with inevitable metaphysical dimensions, and one or more thoughts about life and death. What's not at all obvious is that when you're up against Gravity and its three-dimensional splendor, you can no longer think of anything. It's not only a science fiction movie, but more of a contemporary space thriller. It's happening in real time. That is why it is so absorbing. The movie draws broadly on the style of that dystopian tradition stretching from Kubrick's 2001 Space Odyssey. It has some of their flashes of humor and horror and tension, but it is without cynicism or satire, without monsters or talking computers. A journey into space is filmed. We can see wandering above the skies and far away from the Earth, with two unique astronauts facing difficulties. This film demonstrates a story of fighting for survival in an endless space. There are images that keep the viewer's attention tense until the last minute from the universe. In this environment, the narrative is enriched by constant surprises and unexpected events, charged with intensity and breathtaking of the audience in several places. The camera's slow, descriptive, and often rotational movements familiarize the Doctor's perspective by identifying the viewer's gaze, thus increasing the emotions more. Also noticeable are the shots from afar, as are the lateral faces of the footage showing Dr. Stone inside a claustrophobic space vehicle curled up in a fetal posture, underscoring the vulnerability of human nature. The director seems to like the game with shapes and forms, creating a variety of visual effects, even with lights or splinters that fall rhythmically from above, forming a set that refers to spermatozoa. A series of contrasts are orchestrated in the chaotic vortex of the Doctor's movement, the vast outer space with the narrow interior, the huge large with the vastly small, the smallness of man in the face of the vastness of the universe, the female who, despite the feminist surface, seeks the hearth with the male who fearlessly goes away, is free, rebels, and wanders. For Alfonso Cuarón, who starred on Mexican television and arrived in Harry Potter and the Prisoner of Azkaban and the Oscar nominees, Gravity was a long-suffering life plan. He dealt with it for at least 6 years, changed studios and protagonists, and finally managed to do it on his own. Simple as ambitious, commercial adventure as well as a sought-after sci-fi drama, Gravity is a special, exceptional cinematic case that has already made history. This is because, apart from a technically great achievement, Emmanuel Lubezki's 3D photography is a visual miracle. It is also a model of a virtuoso balance between a creator's artistic vision and the strict imperatives of industry. As for the latter, the film bets on a hearty spectacle, which is realistically dazzling. The close-ups of the two protagonists, medical scientist Ryan Stone and experienced astronaut Matt Kowalski, against the backdrop of the vast Earth, are evocative. The silent scenes of destruction, especially that of the space station, incredibly plausible. Moreover, the frugal plot is reinforced with a few emotional eases, such as the story of her son Ryan, but also digestible, sequestering scripts, the last borderline naive part of the comeback effort, that flatter the viewer, thus preventing him from distancing himself. Alfonso Cuarón, who co-signs the script with his son Jonas, is well aware of the concessions he has had to make. It's not Kubrick, of course, but most of his colleagues would probably simplify things more, when they wouldn't embroider on the small and big details that make Gravity of a great depth. Claustrophobic and agonizing sensation, operatic magnificence, and philosophical quests, Alien, Solaris, 2001 The Space Odyssey, but also Apollo 13. Through them, the couple's desperate attempt, and in particular Ryan Stone, to return to Earth turns into an existential adventure that begins with the cord cutting, the cable that keeps the astronaut connected to the ship Matrix, and reaches the first man to walk on Earth. They mediate a path to endless emptiness, compromise with loss, the power of memory, and the games of imagination. Ideas that, even if refracted through a glossy Hollywood prism, are rare to meet in blockbusters of this range. Gravity is a brilliant and inspired movie cyclorama, requiring neither gravity nor gravitas. This is a glorious imaginary creation that engulfs you utterly, helped by superlative visual effects design from Tim Weber, cinematography by Emmanuel Lubezki, and production design by Andy Nicholson. As you sit in the movie theater, you too will feel the entertainment G-forces puckering and rippling your face. If anyone asks me what Gravity is about, I'll tell them it's a tense adventure about a space mission gone wrong. But once they've seen and absorbed the movie, they'll know the truth. The root word of Gravity is grave. That's an adjective meaning weighty or glum or substantial. But it's also a noun, the place where we'll all end up eventually. The film is about that moment when you suffered misfortune that seemed unendurable, and believed all hope was lost, and that you might as well curl up and die, and then you didn't. Why did you decide to keep going? It is a mystery as great as any in physics or astronomy, and one we've all grappled with and transcended. Since its release, various specialist observers have unsportingly emerged to say that the science involved in Gravity is fanciful and wrong. No matter, what makes Gravity so gripping and so novel is that it behaves as if what everyone is doing is happening in a world of commonplace fact, like a movie about two drivers on a runaway train or a hot air balloon. A movie set in space tends to trigger an assumption that it is set in the future. To sum up, Alfonso Cuarón is one of the quietest creators in Hollywood, having made high-end films such as Great Expectations, I Want and Your Mom, Children of Men. Here it attempts to climb level with a film groundbreaking and unusual for blockbuster data, a bold venture crowned with almost absolute success both on an artistic level and in a collectible that has been scanned wherever it was aired. No film since 2001: A Space Odyssey has so fully communicated the absoluteness of space, its impossible vastness, its obliterating void, yet gravity is existential in a real sense. After it's over, you'll definitely feel stronger, not just for what man can accomplish, but for what it takes to make him believe that he can make it through the great and enduring struggle, as it is important to mention that this film is essentially about a struggle to try to get out of space and into Earth. The movie has one of the best special effects to make the film as wonderful and incredible as possible. It is a strict thriller from start to finish, and it is so well directed that it is absolutely stunning. The 3D is also very impressive as they are up there floating around, so visually it is very extraordinary. Also, in some points there is a real perspective as we are there, and we feel like we are in that suit, having a hard time breathing and losing gravity. And what we can learn one more time is that as humans we want to survive, and we are capable of doing anything. When we face difficulties, we find the courage to get everything on the right track again. We have an inner power that makes us face everything, but in order to do it, it is important to want it so bad. If there is a true willing, we can do everything. Keep that in mind. This movie has a philosophical sense with it too, so thinkers, get ready to rock your brain. The opening scene of the movie reveals that the year is 2092, and humans have achieved immortality. In this strange world, everyone was focused on Nemo Nobody, the only remaining mortal that would die of aging. Nemo is interviewed by a reporter who wants to know about his life, but little is known about Nemo. Even his doctor isn't aware of who Nemo is. Any attempts to uncover his identity keep leading to a multitude of contradictory stories. When he was young, his parents separated. He is faced with the impossible choice of whether to stay with his dad or go with his mom. At this point in the movie, Nemo's life splits off into different realities. One reality where he stays with his father, and one where he boards the train and leaves with his mother. Nemo lives out both of these lives where he experiences different things, some things only being experienced depending on which parent he chooses to live with. It appears that Nemo has different levels of happiness in each reality, but as it seems, no one reality has more meaning than the other. And from here onward, we can see in the movie that Nemo's life is divided and fractured into multiple timelines. He gives a love letter to Elise. He doesn't give a love letter. He becomes a photographer, a TV personality, and a pool maintenance guy. He marries Elise, Jean, and Anna. He is killed by mobsters, drowns in his car, and is killed by a meteorite. All these events happening in different alternate realities. They are all a collection of very confusing alternate realities that are even complex because of the physics of space and time. The main gist of the problem is, what is the right choice, and what are meaningful choices? To answer this and some others, we would have to take a step back and focus on one of the realities in which Nemo discusses about time. He explains after the Big Bang, 3 spatial dimensions and 1 temporal dimension were created. These spatial dimensions, namely length, width, and height, allow us to move freely, but not the 4th one, that is time. He says time as we know it is a dimension we experience only in one direction. This one-directional movement has a huge impact on our decision-making, because as said in the movie, we cannot go back, and that's why it is hard to choose. Once a decision is made, we must live with the consequences. But what makes one choice more meaningful than the other? This question requires a definition of meaning. We need something to weigh our options and base our decisions on them. But if we look to the universe for any guidance for making any decisions, we are likely to be disappointed. Until one makes a choice, anything is possible. This is based on the many worlds interpretation of quantum mechanics, in which an infinite number of parallel universes exist, one in which each possible choice is made. Making a choice determines which of those possible universes is the one you live in. Combined with the idea of the butterfly effect, that a small change can have enormous consequences, This makes every choice seem almost monumentally significant and difficult to decide. The film demonstrates this. Whether Nemo chooses to live with his father or his mother has a huge impact on his life, but so does whether he's a few seconds earlier or later to meet a woman he likes. We experience this phenomenon as random change, bringing us either good fortune or bad luck. In the opening scene, we are introduced with the pigeon superstition. We can relate this to our belief that our choices and actions affect the world in a certain way. But in reality, we know very little about what forces move our lives in certain directions. And that is why whenever something unexpected happens, whether it's good or bad, we always think, what did we do to deserve it? So how can we know what is the meaningful choice? How can we weigh our options to choose what's the correct one? It is the reason why immortality is so appealing to human beings. If we had unlimited time to make every choice however we wanted, we would no longer experience the regret that we sometimes feel after making a decision. We would correct our decision if we made a wrong one. At this point, we are introduced to Nemo's gift. We are told that in the movie that before birth, we know everything. We are omniscient until the angels of oblivion remove our memory. But the angels forgot to remove Nemo's memory, and so he had all the memories of all his different alternate realities and knew all the possible outcomes to his decisions. But this doesn't make his life easier at all. Instead of being enlightened, his knowledge paralyzes him, and he believes there's only one option left. Quoted in the movie, in chess it's called zugzwang, when the only viable move is not to move. By not chasing any path, he thinks that all paths remain open and possible, but he's wrong. Because in this universe, where we are confined in this one-directional temporal direction, which demands decision-making, we cannot not choose, at least not without disrupting the fabric of space and time. And it's the reason that in the timeline where Nemo doesn't make a move is the one that resets in sort of a paradox, where he defies the rules of his own existence and truly becomes Mr. Nobody. The main point is that knowing every outcome is as paralyzing and horrifying as not knowing the outcome. As explained by Professor Ruth Chang in one of the TED Talks, we make choices by weighing alternatives and judge whether one option is better than, equal to, or worse than the other. But this technique is not enough. This technique can work for easy decisions but not hard decisions. She says we need a fourth relation beyond better, worse, or equal to that describe what goes on in these hard choices. I like to say that the alternatives are on a par. When alternatives are on a par, it matters which we choose, but one alternative isn't better than the other. They are in the same neighborhood of value, but at the same time being different in the kind of value, and that's why the choice is hard. Nemo knew every possible path, but this couldn't tell him that his love for his mother was more than that of his love for his father. He couldn't decide whether the heartbreak from Anna was worse than that of Elise's depression. He didn't know which is the right path, and this is the gist of all the problems. We search for reasons outside us, external factors to support us. At the end, we are empty-handed whether we make a choice or we do not. In one of his realities, Nemo approaches Jean to make Elise jealous and decides never to leave anything to chance again. However, once Nemo achieves his goals, he finds himself bored. He feels that he knows himself too well and that nothing is exciting anymore, as if nothing has meaning anymore. One philosopher named Thomas Nagel calls this feeling the absurd. The absurd is when one takes things very seriously, but in reality knowing that nothing really matters. Nemo took his life so seriously that he followed the plan he had set for himself at age 15. Once reaching the age of 34, though, Nemo realizes that the life he has built for himself is not truly what he wants or what is important to him. Longing for excitement, Nemo begins to base his decisions on a coin toss. He brings back the factor of chance into his decisions. This action is a decision in itself. Nemo is deciding to incorporate chance in his decisions. This coin toss method ultimately results in Nemo's death, but stands to prove the point that our choices lead to irreversible consequences. So when we make any choice, we should look inwards into ourselves rather than looking for external factors. It's not about the process of making choices easier, rather it's about realizing that no path is the right path. As Nemo says, every path is the right path. Everything could have been anything else, and it would have had just as much meaning. So it all comes back to us. We have to make our choices meaningful. And as Professor Chang said, you should reflect on what you can put our agency behind, on what you can be for, and through hard choices, become that person. Even if we believe we are on the right path, there will be mistakes, sorrow, ups and downs, moments of regrets when we long for that reset button for another chance. But if we truly act from the heart, if we base our decisions on our innermost voices, we will experience something else. We will find ourselves in a completely different realm where it is possible to love and be loved, to be happy and to realize that even there can be infinite possibilities and realities, our lives can be extremely meaningful. Near the end of the movie, it is revealed that each of the lives that Nemo had lived were in fact all made up. He had imagined these lives at the age of 9 when trying to determine whether to live with his mother or his father. We as viewers get to see his different lives with different levels of happiness and different lifestyles, and make our own decision about which life we think is the best one. The truth remains, though, that each life is just as good and meaningful as the next. The quote, "Every path is the right path. Everything could have been anything else, and it would have just as much meaning," sums up the movie perfectly. No one life was better or more meaningful than the others. They were simply different. The conclusion to be made about this idea is that ultimately our decisions are not necessarily connected to meaning. Be free with your decisions in knowing that you can still live a meaningful life with however you make your choices. Nemo also says at the end, "I'm not afraid of dying. I am afraid that I haven't been alive enough." It should be written on every school blackboard that life is a playground or nothing. Today we are going to take a deep look into a film considered to be one of the best films of all time, 2001: A Space Odyssey. 2001: A Space Odyssey is a 1968 epic science fiction film produced and directed by Stanley Kubrick. The screenplay was written by Kubrick and Arthur C. Clarke, and was inspired by Clarke's short story The Sentinel, and other short stories by Clarke. This film is considered to be a modern masterpiece. What is really interesting is that Kubrick wanted to dive into his viewers' subconscious and arouse their emotions. I think he fulfilled his purpose by demonstrating his point of view regarding the limits of technology, the nature of existence, and the evolution of humans. Researching in-depth existential concerns, scientific and philosophical questions, this film breaks all kinds of cinematic boundaries and becomes a multi-dimensional audio-visual feast. From the very first day of its screening, it left audiences and critics speechless, triggering a variety of strong emotions. However, over the years, it was recognized to such an extent that it was identified as a reference point for science fiction. 2001: A Space Odyssey is a shocking film experience that we've never seen before in cinema. It is an absolutely modern and timeless cinematic saga that even today, 50 years after its creation, time did not dare to touch. At its core, the film is a journey, a summarization of those questions that are both the simplest in their inquisition and most profound in their answers. Who are we? Where do we come from? And where are we going? Let's see the film as it is divided into 4 sections. The first part of the film is the dawn of man, which takes place in prehistoric times to present the first stage of human existence. There we see chimpanzees where their quiet life is being affected by the appearance of a mysterious monolith. Let's take a closer look at this. So welcome to prehistoric times. 4 million years ago, a species of chimpanzees was living together with other animals. Divided into herds as they were, these chimpanzees fought each other to claim lakes with mud and some plant roots for food. They were exposed to jungle wildlife and their longevity was questionable, until all of a sudden a mysterious black monolith makes its appearance and chimpanzees started using tools, became hunters, stood on both feet, and held improvised weapons. Their daily life turned into a war that had, as a result, a brutal murder. At this time, Homo sapiens are born, the ruler of the Earth. With a shake of his wand, Kubrick beams us from the unarticulated cries of our distant ancestors to the music of Johann Strauss. The music is associated in the film with the first entry of man's consciousness into the universe. From the ground, where man was pinned down, to space, Homo sapiens belong to the past. Humanity takes its place, and the second part of the film starts, but with no name. Now humanity is far more advanced than at the start of the film. Dr. Floyd and his team undergo, with secrecy, a mission on the moon. When they arrive on the moon, the astronauts detect the same monolith as in the past, under the surface of the moon, but this time without any of the characteristics that the apes did. With no fear or curiosity, when Floyd touches it, the monolith emits a loud, high-pitched sound. This sound is a signal to the third monolith orbiting Jupiter, and the firstborns that man has advanced significantly and is ready to travel to another planet and eventually continue to the next step of the evolutionary process. Here we are 18 months later to the third part, named Jupiter Mission. A manned mission will embark on a journey to the planet Jupiter to explore the origins of the black monolith. Shortly after the beginning of the second part, the film also acquires political dimensions, showing high-level government projecting a fictitious virus that is about to break out in order to conceal the true purpose of the spacecraft mission. We see two astronauts, Frank Poole and Dave Bowman, as they travel to the planet Jupiter to detect the monolith with the command of the artificial intelligence of the HAL 9000 computer. Meanwhile, their colleagues hibernate in little pod beds. During the mission, the HAL computer that controls all the functions of the starship starts developing emotions, and it is getting more complicated after Frank and Dave decide to turn it down and continue the mission on their own. Hal kills Frank and the sleeping scientists, forcing Dave to kill the supercomputer. At that point, it seems that man's tool had just destroyed its creator. Hal is so manlike that it turns into a man itself that can decide what he wants to do. At the same time, Kubrick wants to emphasize how little and small man is away from his kingdom, the Earth, and has to deal with the miracle of emotions and this evolutionary leap from a machine, a construct of man himself. There are scenes where the work is flooded with emotions, the emotions of a computer. Arriving at the last part of the film, which is called Jupiter and Beyond the Infinite, Dave has reached Jupiter's space and discovered one more monolith floating in space. After investigating, Dave finds himself on a psychedelic, even interdimensional journey through space and time. Kubrick masterfully gives the impression that now in this world, so far from home, man is an ant in a fragile starship. Under the sounds of Jorgi Ligeti's music and Kubrick's magical shots, we understand that we are not only the only intelligence presence in this world, but we are surrounded by giants, titans, and deities. And then a new journey begins. A journey that the human mind cannot fit through a portal into another dimension. In other words, we can see the beauty of galaxies, the texture of colors beyond imagination, the unspeakable unknown. Kubrick, without words at all, uses only the power of the image, and as a magician of cinema reaches the human imagination to its limits to get an infinitesimal taste of vast space. The ending is intended to evoke images, sounds, memories. Its primary purpose is to inspire questions instead of answering them. Kubrick himself, in an interview, he claimed that the ending is not meant to be clear in a conventional way. He wanted to affect people's subconsciousness. What we gather, advanced aliens have been contacting humankind through monoliths to help them develop an advanced technology and a better understanding of the universe. The first monolith helps humans to develop the first knowledge of how to use a tool that becomes the beginning of everything, so we may know what we know through an outside force contacting us. Then a monolith is discovered on the moon that emits to the Jupiter, and then another mission is being carried, where the computer HAL turns on the humans and kills most of the crew. After Dave disconnects Hal, gets into a dimension where he is alone, and there his journey begins. He is part of pure energy. In this dimension, he sees himself at an older age, where he dies, and we see a star child heading back to Earth. What we can impose is that from that point starts a new era of more intelligent existence. Now let's see on a deeper level this film. According to Kubrick, there is a civilization more advanced than us that wanted to give us the opportunity to advance our level of technology, even though we can't figure out why. And the start happens when the monolith appears. To us, these aliens seem like gods due to the fact that they are so advanced in their evolution that we couldn't possibly understand them. Kubrick has described them as beings of pure energy and spirit. Kubrick's God is impenetrable. When Dave is in this dimension, he sees himself as an old man, like a symbolism of the aging of the humankind. After a while, the older Dave dies, and he reaches into the fourth monolith that we see in the film. Afterwards, his spirits are reborn as the enlightened star child. This child is being sent to Earth to carry the wisdom to the people and help them reach the next level in their evolution. The film attempts to tell the entire story of the evolution of humankind, from primitive ape creature of the distant past to the advanced star being of the near future, while also exploring ideas like man's place in the universe, artificial intelligence, and technological progress. Now let's talk about the monoliths. It is said that every monolith represents a stage in our evolution. The first turns apes into the humans. The second on the moon sends a signal to alert this alien intelligence. So humans have become space travelers with advanced technology. The monolith helped them to increase their curiosity about the outer space. But there is this point in the film where Kubrick demonstrates that this technology could possibly harm us and become smarter than humans. But with Dave disconnecting Hal is like saying that humans wouldn't let our machines dominate us. But as humanity, we aren't finished in our evolution, though we have gained so much. And we can see it with the fourth monolith when Dave dies and returns to Earth as a star child. There is always more to learn, so in his mind, we might be able to come over and over again on Earth, each time more civilized and advanced. So this theory makes us optimistic that after our death, we don't stop existing, but we come on this Earth again and again until we reach the point that is meant to be for us. We will reach the stars. We will transcend our current form of existence. We will meet and join with other races out in the universe. At the end of the day, this is a film based on fantasy, inspiring questions. We may never know why we are here, where we came from, how we developed our technology, and if our soul keeps on existing in other bodies. But a good film is considered successful when it doesn't give you the answers, but makes you think. And of course, it would be impossible not to talk about the music, scenario, and direction. He presented a series of innovations such as the slow, unconventional narrative, with the first 25 and the last 23 minutes having no dialogue. 2001 famously only has about 20 minutes of dialogue in its entire running time, and none whatsoever in its first or last 20 minutes. What dialogue there is largely banalities or some degree of exposition. But that was the point. Kubrick deliberately cut out a lot of verbiage to let the visuals tell the story. He was also the pioneer on the technical achievements with the use for the first time in the cinema of on-the-go filming of static models, and the technique of the slit-scan photography and the use of negative filters were used to create the climactic Stargate sequence, which still stands as one of the greatest single scenes in sci-fi history. Action of two different flows of colorful light in the same frame. He had the ability to marry science fiction with philosophy, technology with art, spectacle with spiritual quest, and realism with surrealism. This extraordinary film affected all the contemporary creators such as George Lucas, Steven Spielberg, James Cameron, and Ridley Scott, and became their main source of inspiration for their own great works. Kubrick illustrates his thoughts on the existence of humanity in an unprecedented spectacle, where the action is dictated by the choreography of silence, whispers, and classical music, and the image permanently represents an idea. Even the frenzy of colors and shapes in the scenes of space-time transition, handheld by Douglas Trump's Oscar-winning effects, captures the artificial descent of a duplicator in the labyrinth of the subconsciousness. And he pays close attention on the details. When Kubrick set out to make 2001, he was determined to make a movie firmly grounded in science. His sets on the space station and the Discovery are built to simulate the rotation necessary to create artificial gravity, something never utilized in other films. From his spacecraft interiors to the surface of the moon, Kubrick strove to make the most realistic Space Odyssey he could. By cutting back on the dialogue and deliberately leaving many of the film's ideas and scenes open for interpretation, Kubrick created a surreal and often impressionistic experience that was intentionally enigmatic, raising questions. What if we have turned the exploration of the untold universe into a struggle to solve our natural origins? Do aliens help with our evolution? Are we ever going to find this truth? Who knows?